quickly recap what we've got in this file, okay, so that we can start to push forward with this. If you look here, this is going to this is essentially going to become a server in the future. All right. So I just want to kind of get you thinking about where we're going to be with this. We're going to make an Express server like we used to make, right? We're going to be having things that say like app.get, app.post, app.put, app.delete. And then when you make a post request, that means that you're going to see something like mydata.save inside of that. But we're really going to, even more so, we're going to extract those things out and make them their own modules so they're all plugged into this file. Your servers are essentially going to look like this in the future, just so you have an idea of where we're going, right? Like, obviously, this would not be there. You would have something like this. So, and I'll put all this stuff back in just a sec. Const express is equal to require express. Yep. And then you'd say something like const app is equal to express. All right, you all know this. And then we would want to be down here. So then you're like app dot, we'll say post because it makes it easier to see, to, you know, my food, right? Or we'll just say food. Okay. And then you'll have some sort of callback function, right? And then you're basically just going to say something along the lines of like, you know, my data dot save, whatever, whenever you make a post request. Does that make sense? That's not a functional piece of code. I'm just trying to get you thinking about where we're going. That's where all this stuff connects. When we get back into servers and APIs, which starts on Sunday, then we're just going to start to connect the things that we've been talking about with database integration to a real server and API. Cool? Okay. So, kind of move out of this for a second here. Get us back to where we're at because we do not need Express. Although you should also know, in terms of modules and packages, I've got, you know, my fair share of favorite ones. I love React because it's React and it is a package. But in terms of JavaScript, like helpful tools, Express is so helpful. Node.js has a native version of this built into it. It has the HTTP module, so you can actually make your own kind of Express routing system. I've done that before. It is a nightmare. It takes forever to get it right. It takes forever to hook it up in such a way that you don't have bugs. Express even does things for you, like when you give a JSON object back to someone, you can use response.json. Like that method is there. That's not natively built into Node. That's an Express method. So just so you know, I really like Express. And when we get into Express, I'm going to give you some extra tools and things that will extend off of what your previous knowledge is for it, right? You all had a lot of like app.get, app.post, app.get, app.post. We're going to start to bind all those things to different resources. So it would be like weather.post or location.post. And they're going to live in their own files. And we're just going to do this kind of thing. We're going to say app.use, you know, weather router, app.use, location router, just to get you thinking about it. And then there's going to be a file that basically has for weather, it says weatherrouter.get, weatherrouter.post, weatherrouter.put, weatherrouter.delete. And then we just pull it in this file instead of having like a 400-line server file. Make sense? Yeah, that's the direction we're moving. All right. So what we're going to do is we're going to go into our food schema and just quickly recap what we have here. We have this schema or this blueprint for how a piece of food should exist. Now, inside of my models directory, I've got a food schema.js file, and I'm about to make a food model file. The schema is the blueprint for how your data should be saved to the database. The model is the outline of what you should be able to do with said item. Right? That's why we have those CRUD operations as part of it. Every time we want to work with a piece of food, we want to be able to add something to it, or excuse me, add a new food item, remove a food item, delete a food item, or update a food item. These are operations that allow us to exist against, or excuse me, work against that specific type of thing. All right. So truly, just so you know, this is kind of a data model as well. We're calling it a schema, but it is actually still a data model because we're modeling out how this data should look. We're shaping the frame of our data, right? But then inside of food model, which we create in just a minute, we're going to make a food model.js file. We're going to shape the interactions that can happen against our data. Okay. Both of those are modeling the way that this should work and the way that it should look. So I almost want you to see that as behavior, model the behavior, and model the shape of the data. Does that clarify any sort of like confusion on models a little bit? Okay. All right, and that can get even more confusing depending on the type of system you're working with. Modeling can mean a lot of different things. In our case, we're talking about shaping the data and then shaping the way or the interactions that this thing can do, such as CRUD operations. Good? Okay. So all we're going to do is rebuild our food model from yesterday and test it, and we're going to test it in a very similar fashion. We're going to write tests that are really similar to what you already saw. So what I want you to be doing tonight when you go home, I want you to basically pull up the in-memory model that we made yesterday, and then I want you to pull this one up, and I want you to look at them side by side, and you're going to notice that the test that we have and the modeling is very, very similar. We're just removing this in-memory database, and we're plugging in an in-memory database, but it's one that's being handled through MongoDB server. It's not just an array. It's an actual like mocked version of Mongo. Okay? All right. So let's go ahead and create a foodmodel.js file. I'm going to go in here, turn this on. All right, so open this up. Nope, sorry, gotta make the thing first. We'll go into models, and we're going to touch foodmodel.js. So again, we've got a schema that gives us the outline of the shape of our data. That means, what does this object need to look like? What are the required pieces? What are the non-required pieces? Now what we're going to do is we're going to talk about the behavior that we should be able to do with said model. All right, or excuse me, with said, this is hard to use another term. We're going to call it a resource. Anybody ever heard of a resource before? So like when you go to /cats to add an item to your cats array, cats is a resource. When you go to /weather to add items to your weather array, weather is a resource. Follow? Okay, that's why we call URI, Uniform Resource Indicator. It's a way to tell us what that resource is and where it lives. Okay, so inside of this, we'll open it back up. We're going to go into our food model, and we're just going to say ustrip, as always. And then we're going to go ahead and pull in our schema. So we're going to say const schema equals require. We know that we have a schema in food schema.js. So now we have the ability to pull this, this schema, which gives us a blueprint and an outline of the shape of our data in, so that we can actually interact with that in some way, shape, and form. Now there are methods, right? This is the important part. There are methods that are available to you through the use of Mongoose to be able to add things to the database, find things from the database, find specific things from the database. We're going to use those methods, and those methods can be connected to our schema in such a way that we can just call them to be able to find things from that specific database collection. This represents, do you remember when I said show collections? Collection of food called foods, right? Different foods. So we need to be able to reference that collection in here so that we can say find items in this collection. Find an item in this collection by its specific ID. Follow? Okay. Please.
I use foods in order to find them the one that created my database.
Yep.
As a foods with S.
It's gonna no. You're gonna write in here food, not with the S. However, I got a question earlier, and I told you I don't think it will add an extra S. I could be wrong about that. So we should test at some point in time, and maybe you can do that this weekend. Create something like categories, and then see if it says categories with another S at the end of it. Right? Make sense? Okay. Just to see what happens there. And I'll explore that too, so that I can see what happens. Cool? All right. Because generally when you create a model, just to be clear, you're making a model of a type of data. So each food item, not foods. We're going to make a food item and put it inside of a foods collection. Follow? Okay. So we'll say class food, right? Because we know that we're going to be making a food model. And then we're going to say constructor. Now I want to show you this. You'll often see this pattern. When you see a pattern like this, That means instantiate this food object with no predetermined set of data. We don't have this dot name is equal to name. We don't have some value in here, but we still have the ability to instantiate it. Follow? Yes. So if we want to say, give me a new piece of food, we get a new piece of food. There's just nothing there. Does that make sense? Okay. Say it again. We could, like if we wanted to, we could do something like this on our food item. You know, we could say like name, you know. It will be empty, correct. It's an empty object. Cool? All right. So then we're going to say get. Now check this out. We're going to do things for each type of method that we would normally do, like get, create, update, and delete, right? Follow? CRUD operations. Okay? So, and get is read. It's just we usually use the term get as opposed to read when we're creating methods like this. So we need to get something by its ID. And if you've noticed here, I put ID as an underscore because when we get something from Mongo, we get it by its underscore ID property. Okay? We also know that we are going to be creating something, and we're going to create something with a new record just like we did before, right? And then we are going to update something. We have got to give it an ID. Note the underscore because it's Mongo, right? And then we're going to give it a record. And then if we want to delete something, we simply delete that thing by its ID. Follow? Now yesterday, there was a whole bunch of stuff we did in here. We were dealing with things like filter and reduce. We're not going to do any of that because we have methods that are available to us through Mongoose that just let us do that stuff right out of the gate. So before we go and write this, you need to see the Mongoose documentation because honestly, it's kind of bad. All right. So if I say Mongoose.js, click on this. This is a really good example here of a basic kind of basic resource that you create a model for it, and then save a cat to it. We kind of did this with Apple and food. We just imported it in versus like one file, right? But the same idea. You notice const mongoose equals require mongoose. That pulls in the mongoose module. Mongoose.connect says connect to the specific MongoDB instance that's running in the background to this database name, which would be called test, right? Always use new URL parser, this is part of it. Then we say const cat, which is basically a model, and this is a mongoose model, is cat with a name of string, okay? So all there is a required name, which is a string. And then we say const kitty is equal to a new cat, and then we can say kitty.save, and that will save it to the database. If we wanted to, we could then chain to this, because it is returning a promise, you know, some other interaction. We could get the data back, and then we could tell the user, hey, we saved this thing. We could send them a basic message. We could console log. But there is a way to either pass this a callback function or to chain a then to it. You can do either option here. Cool? I saw a hand. Yes? Yep. Yes. I do not believe you have to do that on a Windows machine with MongoDB. I don't know, so you should look this up. But let me be clear. If I was using the PG module on my Mac or a fresh Linux install, so not WSL, I do not have to put username and password. That's a Windows-specific thing. I'm pretty sure, though, and don't quote me on this, I will test it this weekend too, I'm pretty sure you can just go straight with this in MongoDB. Okay? You absolutely can do this when you're working on any sort of a Linux server. You don't need a username and a password. Cool? So to answer your question, Postgres, because it's hitting at the Windows root level, it was looking for a username and password. I actually think that this will work the way it is. Say that again? No, not yet. So soon we will, right? Soon we're going to be dealing with Heroku and other deployment platforms. Just so you know, Heroku is a deployment platform, right? It allows us to be able to set up pipelines. You can set up like Travis or GitHub Actions. It allows us to provision a database and connect that database. It allows us to deploy our app and build things and get metrics, all that kind of stuff. So does AWS. So when we get into working with AWS, we're going to do a little bit of Heroku work, but we're also going to be pushing things up to AWS and having AWS do the same thing that Heroku's doing. But to answer your question, I think what you're saying is, should this be a hidden thing? Yes, it should be an environment variable. Does that make sense? Because ultimately what's going to happen in the future is it's not going to be running locally. Like when you deploy your application, you're not going to run a local MongoDB instance. You're going to point to a remote MongoDB instance, and you don't want anyone to be able to see what that is. You just pass in here MongoDB URI, and then it's good. Cool? Okay. So if we go to read the docs, right, there's all of this stuff. And it's kind of hard to find things. It's kind of hard to like read through some of this documentation. But basically what I want to show you is that there are some simple methods like this. So if I say animal.find, and then I can actually do things like by name. That's pretty crazy, right? We're going to be working with the most basic possible, which is, just so you know, we're going to be using find one. That means find one specific thing, okay, given some property. We're going to use find. Find is going to return everything back to us. So if we look at our foods collection, find is going to give us all pieces of food in that. Here's an example with that, right? We already used this method. We said db.myapp.find.pretty. You remember doing that? .find is a method to find all the things in it. If we wanted to, in the shell, we could have wrote find one and passed it some sort of object that we're looking for a specific property on that object to be, and it would find it and give it back to us. Cool? We're also going to use find by ID and update. Guess what that does? It finds an item by its ID, and it updates the item for you. Right? You don't have to do anything weird there. It does it. There's find by ID and delete. Right? So I want you to think about this from not a back-end perspective. I want you to think about this from a front-end perspective. When you make a task list, so you're making an app, right, where you add a task or a to-do item, a task, right? So my tasks. Okay? And every time you add one of these things, there's some meta information about this task that sits in the background, because this is really just an object, right? We're just pulling the text from that object and putting it here. When you say, let's say there's a little X next to it like this, and you say X, that fires off a request from your front end to your back end with the ID, and then in your back end, it captures that request in a delete route, which then takes the ID and passes it into a Mongoose method called find by ID and delete, which goes into the database and deletes the item. You kind of see in the connection pieces, we're getting there. We've still got a week or so before we get to that point, but that's how I want you to be thinking about it, right? On the front end, yeah, I'm recording. One more time? Okay. So we're dealing with back-end development. We don't have any sort of front end at all right now, right? But you kind of need to think about where we're going with this, because our APIs, first off, our APIs could be standalone. That means that as a developer, if I just want to consume data, like the weather API, you can consume data from that, then I'm able to do that. But our APIs should also be set up in a way that they can power a front end. That means if I want to make a GET request as a developer and get some information back, I get a JSON object. But as a front end interface, I also need to make a GET request so I can get that object and then put all that information on the page. Every time you add something like a task or a to-do item to a task app, this is an object that has like a description and like a name, and that might be, you know, this information here, right? And then under the surface, there's an ID here too, right? So when you click on this thing, we take this ID, we pass it into a delete, .delete, app.delete over here, which then takes the ID and passes it into Mongo and says find by ID and delete. And then we give it the ID that we just passed through this whole chain, and it deletes the thing from the database. That's where we're going. Just like jQuery, right? Same idea. We're just able to use these methods. The biggest difference, though, is that we're passing through this crazy chain. Does that make sense? Okay, got it. Okay, so let's build this thing out. And again, with these methods, just to be clear, this documentation is awful. I mean, it really is. Like, it has all this kind of stuff, like return this model animal find type, this dot type, callback. Really what you want with documentation is like, here are a set of basic methods you can use, here's what the parameters look like, and then here's some examples. This one is really hard to find what you're looking for in it. They've even gotten better with this documentation over time. It was way, way worse back in the day, but it's still pretty bad, just so you know, okay? And that's a common theme. I thought I hated it for a long time, and then I started talking to a bunch of other developers that hate it too.
They don't even show the promise-based function that it's all based on the callbacks, but like most of the functions are already
You can just use it without a callback, yeah. So that's really, as a developer, we want a quick like, this is what this thing does, and then we can go into the depth of that later, right? So again, this is fairly bad documentation. So we're going to go over here and we're going to start with get, right? Now the first thing to think about here is that we want to be able to interact with get in such a way where we can find items. So if we say if this ID, right, exists, that means we pass get an ID to get an item. Then we need to return schema.find. We'll do find by ID in a minute. I'm going to show you all kinds of different methods on purpose. Okay, we'll do find one, and we'll pass it the ID. Now, could you use find by ID? Yes. Cool. All right. Here's another one. Else, if we don't have an item with our ID, let's get back the whole list. Okay. So we could say return schema.find, just like that. All right. Often what we do is pass it this object, and I think this may even be a required parameter now, and that just says find everything in this. Okay. That's it. It's done. Say it again. We don't need to handle any promises in that. That's a great question. Yesterday we said at the end of every one of these, we're like promise.resolve with our record, right? Mongoose it has promises built into it out of the gate. So when you do something like .find, you can do one of two things. You can pass it a callback, or you can chain it in. Cool? It will handle both of those scenarios. So create, and actually another thing you should know about that is most modern Node.js modules are already permissified. They're already set up in such a way that you can just work with promises. And that's because promises have been the standard for a couple years now. Like, it's definitely been a thing. Cool? All right. So then we've got create record. This one is even easier. We're going to say let new record, okay, equal. Now we brought in our schema, right? So we're just going to say new schema with a record. So now we have a record that's been created, and then we're just going to say return new record dot save. Done. That's it. And if we want to do something with that after we create a record, we can say dot then, right? And then we can do whatever we want with it. Follow? Because this is going to return a promise for us. We can just dot then. Yep, that's exactly right. So normally what you want to do is check to see that it was saved. So if we chain dot then, we can actually get the data right back from it. The thing that we saved, we'll actually get the thing right back, but this time it actually has an ID property attached to it. Does that make sense? So when we save it with just name, calories, and type. But what gets back, if we were to say dot then data, data would actually be name, type, calories, underscore ID. Follow? Okay. Then we have update. Update is also really simple. We're going to say return schema.findById and update. And then we give it an ID. Now this is the important part. We have to give it a record to update. Okay? Technically that will work right there.
I thought we are going to get it, then update.
Nope, don't have to. It just does it. It says find this item, pass it an ID, right? Yep. It's basically going to say find by ID and update. If this ID, we would handle this in a catch block if it didn't exist. Does that make sense? Good stuff. So find it by the ID, give it the thing that we want to update it with. So if we want to update like the name property or something, it will update the name property. You don't have to do anything else there. However, all right, you really got to pay attention to this one. I don't know why they haven't changed this yet. It still drives me nuts. It's been like this forever. If you don't pass it this optional parameter that says new true, you are going to get back the thing that you sent, or sorry, the thing that it was, not the thing that you updated, right? Usually what you want to do is when you update something, you automatically want to get that back, refresh your page with the updated information. If you don't pass it this, you're just going to get back the old thing, not the new thing. Cool? No need to save anything because we're saying when we use this, it saves it for us. Does that make sense? I mean, think about where we're at in comparison to where we were yesterday. We had to build all this stuff out and say promise.resolve. We had to write filter statements and map statements to be able to loop over our data. This just says cool. This one is even easier. This is the easiest one of all. Yep, find by ID and delete, right? And then all we do here is we give it an ID. Oh, sorry. Find by ID and delete. That's it. Done. Right? That's it. So we're going to test it, right? Here's what I want you to see from this, truly. I've worked with a lot of different types of databases, a lot of different types of architectures in terms of how this stuff works. While Mongoose has really awful documentation, Mongoose is a really awesome tool. So that's the weird part about it. Bad documentation, but there is a lot you can do with this, like a whole lot of stuff you can do with it. And these basic CRUD operations no longer us required to write all this crazy logic. All we have to do is say find the thing and update it, find the thing and delete it. These are methods that are built into Mongoose. Now notice I did not require Mongoose in here because Mongoose is attached to my schema. And I exported my schema so that I could use these Mongoose methods. Cool? Now we're going to write tests that look really similar to this. Oh yeah, good call. Thank you. That's happened a few times actually. Quick story because I like to give stories. In 201, when you're learning in 201 like RM and RM-RF, which you don't do because that's recursively removed with fire, right, or force. We had an instructor in 201. It was day one of 201. Students were all excited, and he's really good too. He was up here and he was talking. He was like, and what you don't do is you don't type RM-RF, and he typed it, and then he kind of walked away. Was like doing his thing, right? Walked back up here, presses enter on accident, and he did this at the root of his computer, and he's set it up to say no sudo, so he doesn't have to do sudo or anything like that. Just took the whole machine down, like the whole thing just crashed. It was crazy. I'll try to find that video and show it to you sometime. It's pretty funny. So anyway, be careful. That's your lesson of the day. All right, so I'm going to close this stuff out so I can start fresh here. Now what I'm going to do is I'm going to write tests. All right, we're going to write tests for this. Oh, I'm in the wrong file. There we go. Did we make a test for this yet? Nope. Okay. So we're going to touch a test for this, and really all that we're going to do is we're going to create a test for a food model. So the idea here is that we are testing our food model. Our food model uses our food schema. Does that make sense? So we'll just say, and actually the easiest way to write this one would probably be touch food.test.js because it's all based on the same concept. So open it back up, go into our test, and then we're going to be done after this. So we'll go to tests, foodtest.js. We're going to start with use strict. All right, and we're going to do the exact same thing we did yesterday. We're going to pull in our food model. We're going to create a new food item, and then we're going to check to see it can create a new food and it can get food. I want you to try update and delete on your own. We already built those methods. All you have to do is test them. Cool? So we will go with require. Yep. So we'll say, actually, you know what? We need to start with this. Hold on. This is where you need to kind of see what we're doing. So we're going to say @CodeFellows, and I'll talk about what this means in just a second. Super Goose. I don't need to assign this to anything. I just want to pull the module in so I can use it. We have been doing things like, that means we need to install that, by the way. We've been saying like const app is equal, or sorry, const express is equal to require express, const, I don't know, mongoose is equal to require mongoose, right? These are all third-party packages that live at those names. We have an organization specific to CodeFellows on NPM, and then we have packages that are attached to that organization. So that way you can go to CodeFellows npm and you can look at all the different packages that we have. This is one of the specific packages that we've got. And this package is a combo. The reason we called it SuperGoose is so that we can deal with an in-memory thing that we can talk to. So that's almost like super agent, right? It's like this third-party kind of engine, and then Goose being Mongoose, right? We just kind of put this thing together so that we have this in-memory running version of MongoDB. It works exactly like MongoDB. It is built off of something called Mongo Memory Server. This is a mocked version of MongoDB. Cool? All right, got it. So we'll pull that in, which means that right out of the gate, we should probably just jump back in here, and we should say npmi. This is where you have to kind of know what's up. You say @CodeFellows / and the name of the thing, which is SuperGoose. Just like that. It'll install it just like that. Oh, maybe not. Hold on. I thought it was @ Maybe it's. Hold on. Here, we'll check this out. If it's been a while since I've installed like a rooted thing like this. Nah, I'm not gonna do that right yet. Hold on. Let's do this. Here's how I'd find out what's up. Yep, we say CodeFellows SuperGoose npm, and then this should tell me right out of the gate when I click this how to install this thing. Oh, Code and Fellows. Yeah, you're right. That's probably what the issue is. But we should still look, right? Let's look anyway. So this says, great job, CodeFellows. No documentation.
Oh, it's the right side. That side.
Did they just change it?
No, the right side here.
Oh, there it is. Yeah, okay. But I'm mad at CodeFellows. Truly, I'm mad at CodeFellows now. That gives us it right here, which is what I did. I just put CodeFellows all one word, right? This should have a whole README doc, and it doesn't. So that means, as the boss here, I get to say somebody go write READMEs for this, and that's exactly what I'm going to do. I'm going to be like, yo, you need to go write a README for this. Cool. All right, awesome. That's why READMEs are so important, because I was trying to look at documentation and it wasn't there. Although I have the installation key, I still want to know what I can do with it, right? Cool. I know what it is, so I don't have to necessarily worry about that. So then I'll just take this thing and go boom. That should install it. And then also, just so you know, you can also install versions of things. Like if you said npm install or npm I react at 8, that's going to install the most recent version of React at version 8. Right? If I said React or npm install express at 2, it's going to be the highest version, but only at 2. Cool? All right. So this is, if you notice, look what it's doing. Downloading MongoDB. It's setting up MongoDB memory server because it's going to interact with our information exactly as if it was MongoDB. We can use the same exact methods. Cool? All right. So let's let that install, and then we'll write the tests, and then we'll be done. Come on, install Mongo. That is taking a really long time. Is there a problem with the network? Okay. All right, so the challenge with this whole thing is that there's a problem with the network. So let's give this a second. You know what? I was working on this yesterday. I have a version already in here. I could just go into that. And that way, but, you know.
How about you write the test?
Yeah, let's just write the test. That's exactly right. Yeah, that's what we should do. We'll just write the test while this is working. So, okay. Good call. I don't know why I didn't think of that. All right, so here we go. So we're going to say const food is equal to require our food model. And notice that this is capital because we are pulling in a constructor, right? It's a class that we can then instantiate. So then here, I'm going to say, yep, good. I see like some random conversations. We good? Okay, just checking. So const food is equal to new food. And again, I'm not passing it anything, right? It is going to automatically instantiate this just with an empty object. so that we can add stuff to this food. Okay? Remember, I said constructor nothing? Okay, good. All right, so going down, we're going to say describe just like we did yesterday. Food model. We're going to pass it a function, right? And then we're going to do our outline. You should always outline this because ultimately this is TDD. We're doing it after to get used to it, but in the future you outline it, which is going to automatically fail your code. Then you start writing your expectations, which is automatically going to fail your code. Then you start passing all that stuff. Cool? All right. So we'll say it can make a new food item, which is create, right? And then we know that we're going to do two. It can get food. So it can get a food item. Now, again, I'm showing you something different than before. I just said it can make a new food item. It can get a new food item. You can also do something like this. It can create, it can get, and then usually what that tells the person looking at the test is that there is a method called create and there is a method called get, right? These are decisions that you get to make. So here we'll just say let object equal, we'll do a name, all right, we're going to say test food 1, okay, and then we're going to do something like calories 999, right, and then we'll do something like type of, we'll give it fruit. Okay, we follow? I want you to be very careful with the naming of your test objects. Don't call them, you're going to see demo code too that's going to say like, you know, let name equal pizza or whatever. I don't really like that personally. As someone who deals with like a lot of applications that get built out with tests, usually you want to have a set of test data that is clearly a set of test data so that there's no confusion when you're doing things like data migrations and moving things around to put them up, you know, on a deployed database instance. This is clearly a test item. Cool? All right. So we're going to say return food.create, and then we're going to go ahead and pass that an object. Because Mongoose, right, let's go back real quick for this. We go here to our food model, create returns new record.save, save returns a promise. So I can just simply chain to this. Yep, that's exactly right. So we'll say then I get a record back. Then we're going to basically do what we did before, right? We're going to test to see if the information on that record is what we expect. So we'll say object.keys. It's the same idea. Object.keys with our object.forEach, we're going to get an array of keys. Okay, and for every single key, we need to check that that equals the object keys that we have up here. We don't know our ID. We cannot check our ID. We can check that our ID is a string, though. Hint. Cool. Okay. So we'll say expect. Let's see, record to the key, which means this thing that we actually got back. So my returned object from Mongoose dot name, right? That's what that's basically saying, right? Equals, yes, that's exactly right. Dot to equal, and then here we want to say object to the key. All this is saying is we've got this test object. We're going to save this object to the database. Okay. We're going to get back a new object, which is all of that plus an underscore ID character. And we're going to check that all of these properties are still exactly the same as what we got back from Mongo. Follow? Okay. Then we can say it can get a food item. And here we're just going to find a food item. So we'll do the same thing. We're pro level. We want standalone tests. But, you know, copy paste that to make it easy. And I'm just going to say 2. I'm going to go with 555 or something like that, right? Some obviously not what it should be thing. And then we'll say, what do we have? Fruit and then vegetable, right? Okay. And then let's return food.get. That's exactly right. So we're going to say food.get. Actually, no, we're not. No, we're not. If we say food.get, we don't have any food items in this yet. These are standalone tests. We got to create it, then we can retrieve it. All right. So we'll say food or return food, and we're returning because it's returning a promise, right? Return food dot create, We're going to pass it our object. Okay. Here we go. Ready? Dot then we get a record back, which is that whole thing from MongoDB, which includes that underscore ID, which then I can say return food.get. We're going to say not this. This doesn't do anything. That does. Because MongoDB, when it gives me a record back, it gives me an underscore ID, right? So return food.get record.id. So now I've got a specific piece of food. We all follow so far? Dot then, and we'll say food item. It could be data. You can call that whatever you want, right? That's representing what we get back. I'll use food item for now to help you think through it. And then here, we're just essentially going to loop through those keys and make sure that they're the same. So we'll say object. Object. We're using the object constructor. So object.keys, right? We're going to pass it our object, which is just the one that we made up above. That's our test object, right? Dot for each. We're going to get a key. And for every one of those keys, we're going to expect food item to the key to equal object to the key. So we're just, this is the line that I want everybody to really pay attention to. We're just saying expect what came back from Mongo to equal what I stuffed into Mongo, because they should be the exact same thing. The only difference between this one and this one is I have an underscore ID now attached to it. So you can never test the actual data of your ID. You absolutely can check, though, the type of information on your ID, right? Everybody follow that? Okay, so let's run this test, see what happens. Yes. So let's start here, and then I'll build from that. So this expect statement is saying, let's expect that the returned item from our database has the same set of keys. And when I say keys, I mean properties. So does that have name, does that have calorie, and does that have type? Follow? To equal the object key, because these have name, calories, and type. Make sense? Right? But we're also going to get an object back that has this. When we get our object back, it has this thing attached to it. Cool? All right. Yes? So we want, really what we could do is we could, oh, why do we create it here? Okay, so let's talk about that. Because these tests are standalone, meaning that they do this one time and then they're done. We want to test that these things actually work as expected. Each test. Yes. So we made no, hold on. No. It's another object. It's a separate object. So yes. You follow? Okay, cool. I still want to talk through this one more time, though, just to make sure, right? So check it out. It can get a food item, because this one has two returns with a create and a get. First, we create the item. Then we save the item into the database, because our create hook just says .save, all right? Then we've got a record from the database, okay, which we can then use to get that specific record back, because we now have that. Follow? This right here, this record is equal to this. So I'll comment this. Yep, it is this thing, right? Oh, it is this plus this. Follow?
Yeah.
Right? So that's why when we say get record._ID, that's our record, which grabs it by this. And then we get that back, and then we just make sure that we still have name, calories, and type. Follow? All right, let's run the test and see what happens. Yes? You're saying do something like this. If I'm understanding, you're saying like that, right? Is that what you're asking?
Yeah.
Yes, we could. We could do that. We could also do that too, but we want to check. Yeah, I see what you're saying. I think it's best to create objects that are unique for every single test. That's the idea here.
Because if the first test fail, then the other
Yes,
test is not
the other
fail.
test will continue to work. That's exactly the point here.
Then the other test.
Yep. And what we're going to end up doing, so what we don't have to do here, because we have a memory server, I want you to think about something else too while we're talking about it. We're using a memory server, which means there's not an actual database on our machine. As soon as we stop this application, right, gone, there's no database anymore. It's in memory, right? It's while my app is running, okay? However, if we were to write tests, and we used to, before we had access to Mongo memory server, we had to do this. We would have to have hooks that say, before each, create this object. After each test, run a function called cleanDB that finds that object and removes the object from the database. We don't have to do that here because we're using an in-memory server that's just going to be done when we kill our app. Follow? So we used to actually have to go to the database, save it to the database, and because we didn't want test data just constantly hitting our database, we didn't want conflicts in our database, we had to write these things called hooks to hook into that and delete everything beforehand. We don't have to do that anymore. So I'm going to run this, and then we are done.
Test one.
Ah, good call. So let's jump back in here. Let's go into package.json. We have this, echo thingy here, which we don't want. If you don't already know, all the echo is it's a bash command to just print to your console. That's it, right, in your terminal. So yeah, that's all it does. It just prints. Verbose, and I'm going to show you all some cool stuff with that in the future. I've got all these bash things that are really cool that I'll hook you up with that do fun stuff. Verbose, and then we'll say coverage. Coverage does two things. It gives us a coverage report, and then it actually creates a coverage directory with a coverage report in it, right? So we'll go over here, and we'll say npm run test, and we'll hope, oh, what do we do? Aha, just command not found. So if we look at our package.json file, it says you installed that, and you installed that. Truly, that's one of those things that happens all the time. Like you'll just work with React, and you're like, import React, and you're doing your thing in React, and then you go to run your app, and it's like, can I find module React? First thing you do is just say, oh, I forgot to install this. That's almost always what that means. Cool. There's some other things too. You probably experienced other errors that became common in 3.01. I bet a lot of you tried to run your servers when you were already open on a port, and you would get this E in access port kind of error, and it would tell you, sorry, you're already running servers on a port. There's certain things like this that you just get really quick at recognizing. You don't even read them. You just look at the pattern, and you're like, yep, I know I did something wrong there, right? Also, I've been asked these things before. There's warnings, and then there's actual deprecation things. This is saying that these packages are probably going to have some sort of deprecated piece, or there's some sort of dependency issue that could exist with them in the future, but it's probably not going to break your app. If you get an actual error, or if you get something that says dependency has changed, then you can get into a situation where your app may not work, and that's where package lock comes into play, because it locks dependency versions. Cool? So we'll say npm run test. Cross. Oh, one failed. What? Cannot find module food module. All right, what do we do here? It's the path, right? So I said, let's look at our path. We need to go back one, and then we need to go into models. So we go here. We rerun. It's always stuff like that, right? It's two passed. Yay! All right, so I'm going to stop the recording now, and